My name is, thank you. Also, I always forget to start the recording. My name is Dylan, and I'm a student here at Texas A&M. I've been working for HPRC for as long as I've been here. I got here in 2017. So yeah, I'm a student technician over there. I'll be graduating soon, and so I've been using the clusters for quite a while. So the goal for this primer is to kind of give you the quick start guide for Terra in video version. So by the end of this, you should kind of be familiar with at least what Terra is and sort of how to use it in like a very high level sense of that. So to kind of get started, the very basic stuff is connecting to the cluster. If you're a Windows user, you're going to want to follow along using MOBA Xterm. You can also use the portal. I'll show you how to do that in a few slides. MOBA Xterm is a free SSH client. So typically when you connect to the clusters, you're gonna remotely access the cluster using SSH, which is a command line utility in Linux. MOBA Xterm is just a graphical application of that, freely available, and it's also got some other features like SFTP, so you can transfer your files and stuff. It's free and it's pretty easy to use. You could find it by Googling MOBA Xterm or going to that link that's on the screen. And then you'll click the green button, the installer edition. But without further ado, let's talk about Terra. Actually, let's talk about our resources. So if you were here this morning, this slide will look very familiar to you. This just kind of highlights our resources. So Terra is our 320 node hybrid Intel cluster from Lenovo. It has an omni-path architecture, interconnect, so different from Grace. These are Terra is the older cluster of the two. Grace was just fully deployed this past summer. So Grace is going to have the newer hardware. Terra has broadable processors and does have some fine nodes. It has a few nodes with V100 GPUs, but most of the nodes on Terra are going to have 64 gigabytes of memory. The GPU nodes that are on Terra are going to be NVIDIA K80s. Whereas with Grace is a 925 node, so a little bit larger, cluster from Dell that uses InfiniBand HDR100 as its interconnect. And then it has a wider variety of GPUs on Grace. So we have A100s, RTX 6000s, and T4s. And the nodes on Grace use the Cascade Lake processor, also from Intel. The other two clusters that we just, Faster just got recently kind of deployed a little bit more, and Vital's been there for a little while. Faster is a 184 node cluster from Dell, also same interconnect, InfiniBand HDR100. Faster just has a wider variety of GPUs. So it's got the A100s, it's also got A10s, A30s, A40s, and the T4s once again. And they're distributed and composable via liquid PCIe fabrics. Oh, and the CPUs over there are based on the Ice Lake microarchitecture. And then Vital is the 24 node Dell cluster using Skylake processors, so a little bit older processors, 40 gigabit Ethernet interconnect. And the goal with Vital is actually an acronym, which stands for Virtual Data Library. That's why it's kind of stylized like that. And it's supposed to provide a secure and compliant computing facilities to conduct research projects. So if that kind of sounds like something that you might need to access, send us an email, send HPRC an email, and we can kind of work out access to Vital. So, okay, let's talk about Terra, the reason y'all are here. So this is a picture of Terra. Terra physically sits on the College Station campus in Teague. So if you know where Help Desk Central is, it's actually like, 2 floors above? It's like the second or third floor of Teague in the data center over there, kind of towards the back. But that's what it actually looks like. That's Terra. Each of those green lights you see is a rack with a node inside of it. So on Terra, each node has 28 cores. They're all dual socket. So it's 2 actual CPUs with 28 cores on them. There's 3 login nodes. Again, most of the compute nodes are going to have 64 gigabytes of memory. That's going to be 256 of those. Then there's also the KNL Knights Landing Knights Landing nodes, And those nodes, we don't charge SUs on them. They're not very popular. There's like 16 of them. So if you need a PHY card for as your accelerator, you have an option there. The most available accelerators or GPUs on Terra are going to be K80, the NVIDIA K80 GPUs. Those have more memory than the standard compute at 128 gigabytes, and there's 48 of them. And then we have those 4 nodes that I talked about that have the V100 GPUs. V100, the Tesla V100 GPUs, they look really cool. If you ever Google a picture of them, they look really, really cool. Those have 192 gigabytes of memory. And there's 4 of those. So those are always kind of busy, but they're a little outdated now. So if you need fast GPUs, you'd probably be using Grace. So a good thing about learning to use Terra is that Terra and Grace share the same job scheduler. We're going to talk about what a job scheduler is and how to interface with it in a little bit. But if you can understand the job scheduler on Terra, you can understand the job. It's the same job scheduler on Grace. So if you understand it on Terra, you're good to go on Grace. So here's kind of an overview of how you would use our cluster. And this is the same for Grace as well. You just replace Terra with Grace. So if you're on campus, you connect to the campus network. From the campus network, and then your local machine or your office computer or wherever you are, you SSH into a login node. So when you SSH to Terra, you land on the login node, and from the login node, you create a job or you submit a job that's already been created. The job is just a text file that has instructions to the computer that says, okay, I want to launch, let's say MATLAB, for example. I want to launch MATLAB, and I want you to allow me to use 10 gigabytes of memory, 5 cores for 1 hour. And then you take that job file, you submit it to the job scheduler, AKA the batch manager. And the batch manager then puts your request into a queue and waits for the resources to become available, where it then runs your job on a compute node. And then once the job is run on the compute node, the output files are placed wherever you tell them. You specify where to put the output in the job script file. It's typically wherever you submit the job from. So if you submit it from your Scratch directory, the output just gets sent to your Scratch. That might make a little bit more sense in a second. And then if you're off campus, you do all that same stuff, except you connect to the VPN before you log into the login nodes. So takeaway from here, to access the clusters, you need to be either on campus or connected to the VPN. So if you're not working from A&M's College Station campus, let's say you're still out of town, or maybe you're on vacation and you want to make sure that your job gets submitted, VPN in, SSH to the login node, and then you could do all of your job management from there. So accessing Terra. Like I said, the SSH command is required for accessing Grace or Terra. If you're on campus and into your terminal, you're going to type SSH netid at terra.timely.edu. If you're off campus, first start up the VPN. You could follow that link right there, u.timely.edu/VP network to figure out the VPN. I'm sure everyone's done that by now. And then you SSH in. The clusters do have 2FA enabled through Duo, everybody's favorite. So every time you connect, every time you make an SSH connection, you have to authenticate with Duo. Yeah, that's pretty self-explanatory. So SSH programs for Windows, MOBA Xterm is the way to go. That's the one I was kind of preaching at the beginning. If you just Google MOBA Xterm, you could download it. It's pretty straightforward to download. And then as far as using MOBA Xterm, it's basically a Linux terminal on your Windows machine with a little bit more bells and whistles. So you just hit start local terminal and then you can connect. Or you can use PuTTY. PuTTY is MOBA Xterm, but super bare bones, just SSH capabilities there. PuTTY is available on all the computers at A&M, like the OAL machines. I think MOBA Xterm is now. I know that they were installing it. So if you go to the library, you should have MOBA Xterm. If you're on a Mac, like I am, you can just command space and then terminal, and that'll open up a terminal, and you could use that to connect. That works fine too. Same deal with Linux, just open up your terminal. Question. Oh yeah, so the slides are available. Let's see. hprc.timely.edu, short events, short courses. Let's see. They might not have been They will be here, yeah. Yeah, they will be right above Introduction to Linux. I don't think the update was pushed yet. But yeah, if they're not there right now at the end of the course, they will be there. Okay. So accessing Terra, yeah. So if you don't want to install an SSH application or you don't want to use the terminal, you could also go through the portal. So the portal, it's a web portal that gives you access to all the clusters. Well, I think right now it just gives you access to Terra and Grace. So if you go to portal.hprc.tama.edu, it's going to prompt you to log in with your NetID and password. And once you log in, let me show you that actually. This is portal.hprc.tama.edu. And then here's your options, Terra or Grace. Let's go to Terra. Okay, now it's asking for my stuff. And when you log in, it's gonna duo, like always. And this is what the portal dashboard looks like. So from the portal, you could do basically anything. You could launch GUI jobs. So if you want to use the MATLAB GUI, you want to use the ANSYS GUI, interactive apps, and there you go. There's all your GUI applications. If you want shell access, so you want to start terminal on the compute on Terra, right here, Terra shell access. Boom, you hit that. I think you type your yeah, you do. Type your password in, and then duo once again. And now here's a local terminal on Terra. So you could do everything like ls and cd to move around, or all that good stuff. Okay, and the last notes here are that login sessions that are idle for 60 minutes will be closed automatically. So if you SSH in and then go AFK for a second, you will be automatically logged out after 59 minutes and 59 seconds. Similarly, on the login nodes, any processes that run longer than 60 minutes will be killed automatically. So the idea here is that the login nodes are for logging in and modifying your jobs and then submitting them. The jobs themselves, the actual processes like the MATLAB code that's going to run, it's going to run on a compute node. It shouldn't run on the login node. So if you log into the login node and then you run your MATLAB job, or you have a Python script that does some work, first off, you shouldn't be doing that. And second off, if it runs longer than 60 minutes, it's just going to get killed automatically. So you're kind of just wasting your time, because then you're just not going to get, you're going to get incomplete output. Also, the last two that are in red, the top one is kind of more important. Don't use more than 8 cores on the login nodes. Again, similarly, you shouldn't be running your jobs here. You submit your jobs to the job scheduler here, and then they run on the compute node. If that doesn't make sense, we're going to talk about the actual commands to submit a job. So just kind of keep in mind that you probably shouldn't be doing anything like Python app.py on the login nodes. Let me present this again, sorry. That's because it's a shared resource. So like there's at any given time, there's a decent amount of people connected to the same node that you are. So if you start using a whole bunch of cores and memory and resources, you're going to disconnect them. Worst case scenario, you lock up the node and then we have to go restart it, which can be troublesome and annoying to other users. So yeah, just try not to run stuff on the login nodes. Also, don't use a sudo command. That one's in red, but you really can't. Like if you tried to use sudo, it's going to tell you not to do it, and then if you still try to do it anyway, it's not going to let you do it, and then it's going to email us and tell us that you tried to do it after being told no. So just don't do it. You won't need anything with sudo. If you think you need something with sudo, send us an email and we could figure out what you need, and then we could do it for you. But yeah, just don't use sudo. Sudo is like the root. It's like the admin access. It's saying like, I'm an admin, let me do this. So okay, first pop quiz. Which one of the following is not an HPRC cluster? Is it A, faster, C, Grace, D, Terra, or B, Bozo?
Bozo.
Bozo, yeah. Thank you. Yeah, it's Bozo. So faster's the one that just got deployed. Grace has kind of been, it's the big project that we've been deploying for a while, and I think correct me, one of the staff members, correct me if I'm wrong, but I think we just like officially did the full 100% like SUs being charged, allocations being delivered at this fiscal year, which started in September. And then Terra is, at this point, it's so sad to see Terra called the old computer now, but because it was kind of the newer computer when I got here, so I'm like, oh wow. But anyway, yeah, so Terra is kind of the older one, but yeah, good job. Okay, two-factor authentication. I'm gonna skip this. Everyone should kind of know how Duo works by now. Pretty self-explanatory. Set it up. You saw what Duo looks like on when I logged in. After your password is entered, it says, okay, Duo push or call or text message. And then, yeah. Okay, so file systems and user directories. When you see file system, think hard drive. So there's basically two file systems, which as a user translates to, for you, there's basically two hard drives that you have access to. You have your home drive, and then you have your scratch drive. So your home drive is where you connect to all the time. When you SSH in, you're placed in your home. Your home is gonna, also these drives have two limits put on them, a space limit and a file limit. The home directory, home drive has a limit, space limit of 10 gigs or 10,000 files, whichever you hit first. So if you have 10,000 empty files, you're still gonna be at the limit. If you tried to upload 11 gigs of data to your home, you're gonna upload 10, or I guess 9.99 gigs, and then it's gonna kill it and say, hey, there's no more space. You want to be putting the data that you're going to work on and your actual like work stuff, so the actual code that you're using, you're going to put that in your scratch. Your scratch is the other drive that you have access to, and it has a default limit of 1 terabyte or 250,000 files, so much larger right off the bat. It's intended for temporary storage of large files for ongoing computations. The keyword there is ongoing. We have run into the issues in the past where users request increases in their quota, which is okay if obviously some data sets are going to be larger than these default limits, and we can accommodate that. However, we can't accommodate that indefinitely. Obviously, there's a finite amount of resources or space that we have on these resources, and we want them. We want as many people to use them as possible who need to use them. So we can't give you 30 terabytes for forever. If you need an increase above these default limits, send us an email, help@hprc.tema.edu. It's like all of our website, and we'll work to accommodate you. We do have some new practices now regarding like some procedures for size increases. But if you send us an email, we'll work through those with you, and it just involves getting permission from your PI, or at least an acknowledgement from your PI, and a little bit more documentation. But we can accommodate most requests. You can see your quota by using this command right here, show quota. So let's go to Terra. So here's my terminal. Let me close all this other stuff. Close and close. And clear my screen and SSH. Just do this, Dylan@terra.temu.edu. So this is gonna log me into Terra. Everyone's favorite thing, do the Duo. Okay. So actually, right off the bat, as soon as you log in, you're gonna notice at the very bottom, the last thing you see when you log in is actually your quota. So we automatically print that out to you. But in case you want to see it again, you could say show quota, and that gives me my usage. So I see my home is using 3.6 gigs out of 10 and 4,700 files out of 10,000. My scratch is using 11 gigs out of 1 terabyte and 75,000 files out of 1 million. So off the bat, you'll notice that I have an increased file limit here on my scratch, but my home is still the default, and that's because although we can accommodate most requests for increase in your scratch, we will never. It is our policy to never increase a user's home directory, and that's because the home directories get backed up. So we have a lot of users. There's a couple thousand of y'all. So backing up that many home directories every night is a monstrous amount of data, and it can get very, very big if we start increasing this amount for people. So home, apologies, but home will never be bigger than 10 gigs, 10,000 files. If you need an increase in your scratch, you could send us an email and we could try to work through it. But again, show quota is the command to see your quotas. If you are working in a group, so let's say that you're in a research group and you guys are all using Terra or Grace, and you guys need a space where all of y'all can put your files, like a group directory, we can accommodate that. That begins with an email to us, as we'd be the ones to kind of create the groups, add you guys to the groups, and stuff like that. But that is a solution that we do offer. So just let us know if you're working in a group and you want to share files. And then the last one in red, don't share your home or scratch directories. That message there means if you're working in a group and you want someone to have access to your files, email us. Don't make them public to everybody, because then if someone accidentally messes with your files, it's very time consuming to kind of roll back those changes. So you do want to still practice your good cybersecurity principles and have your stuff restricted to only those who need it. So just don't make your stuff super public. Software. Okay, so software on the clusters. There's a lot of software on the clusters. So much that we're not going to talk about every piece of software listed because that's a whole lot of software. We have wiki pages. So hprc.tamil.edu/wiki. It's like the central hub for all of our knowledge. We're currently working on upgrading the wiki to a more, right now it looks a lot, it's a wiki, so it looks like Wikipedia. Can't imagine that. Who would have thought, right? But right now we're in the process of upgrading it to kind of a system that's a little bit more pleasing to the eye. So we are making changes there, but as it stands right now, it still has a ton of great information if it doesn't look super pretty. So apologies for that, but hprc.tamil.edu/wiki is where you should go if you have any questions on any of the stuff we talk about today. It is literally like the wealth of our knowledge. So this page right here has all this, it's the software page on the wiki, and the page beneath it has the software for Terra. So the software that's on that page, it's going to show you all the software that's there, but some of the software is license restricted. And then there's basically two kinds of license restricted software. The first kind is software that you can't even see because it's license restricted. An example of that, oh, nice, not right now. An example of that would be Orca or Gaussian, right? Those are, I believe those are two software that are, you need to be in a special group to access them. So it's licenses that are paid for by a specific research group that use our cluster. And since they pay for the license, and that license is maybe only for like 4 users, only the people in their research group can use it. You can't even see that software. As a regular user, you wouldn't even be able to see that it's there. You'd have to request access. So to request access, you'd have to contact the license owner, which is typically the professor who runs the research group. For software installation, you can install your own software. You typically install a software in your Scratch directory because software is going to have a lot of files that it needs to create. If you need help installing the software, you can send us an email and we could try to install it ourselves and then send you guys the steps that we took to install it in our own Scratch, and then you just replicate that in your Scratch. However, a lot of software is already installed in the module system. And I think the next slide talks about the module system, but then the last line says, don't run sudo when installing software. Again, if you think you need sudo, you can install most software without sudo. And if you can't, it might already be installed. So if you are trying to install software and you reach a point where like you don't think you can go any further because you need to use sudo, send us an email and we'll help you out. Okay, so that is for installing software on your own. A lot of software is already installed and it's available as modules. So the reason we use the module system is because, well, there's a ton, first off, there's a ton of different software. And then there's a bunch of different versions of the same software. So in this example here, it's just showing MATLAB. So MATLAB is a good example because, well, everybody kind of knows what MATLAB is. And then everybody knows that there's different versions of MATLAB. So there's like yearly releases. So you've got MATLAB 2018, 2019, MATLAB 2020. And what if one user really needs to use MATLAB 2019B? Well, that's where the module system comes into place. So you can, let's demonstrate that. So on Terra, I'm going to Control L to clear my screen, and I'm going to say module list. So module list says what modules do I currently have loaded? I just logged in, so I don't have anything loaded. I haven't done anything. I want to use MATLAB. So when I say MATLAB, bash gives me an error and says bash had an error with MATLAB, and the error was command not found. I don't know what you mean by MATLAB. What does that mean? So using the module system, we could load MATLAB so that when I call MATLAB, bash knows what I'm trying to do. It knows which specific version of the software I want to load. So I'm going to say module spider MATLAB. And this might take a little while. So module spider, it's searching the module system for all modules matching MATLAB. Terra was slow this morning, so I have a feeling this might take a little long. Yes. So the question was connecting to the Terra cluster and all the clusters. When you log in with your NetID and then your NetID password, but you have to have an HPRC account. So yeah. So to get an HPRC account, while this loads, I will just show this. Our website, hprctama.edu. Accounts, apply for accounts. And then you log in. And then you go through this, and you could just put student, and then it'll you go through the application process. It's really, really simple. If you're a student, they typically get approved in like one business day, so it'll probably be approved by Monday. Since it's kind of the afternoon, I don't think it'll go through today. But yeah, you'll get access, and then you log in with your NetID and NetID password. Okay, so it looks like the module spider command worked. So again, I said module spider MATLAB, and this said, show me all the modules that have MATLAB in the name. So we see a whole bunch of different versions from 2016 all the way up to 2020. And then this one, which let's ignore this one for now. So let's say I want to use MATLAB 2021, because my work is like cutting edge and I need the latest version of MATLAB. I'm going to Command C to copy this name right here, this version. And I'm going to hit Q because my little prompt is not there. So I'm going to hit Q so I get my prompt back. And I'm going to say module load and then paste in the name of the version I want. Enter. Takes a second to do the behind the scenes magic. Takes a little bit more than a second. Okay. So what it's doing right now is it's adding this version of MATLAB to my path. So okay, so it's done. So now when I say module list, the module system says, okay, you've currently loaded modules. You've got MATLAB 2021A. Pretty simple so far. And now when I say MATLAB like this, all of a sudden I don't have an error. It says, okay, starting MATLAB from host T login. So now I'm running MATLAB on a login node, which if you were paying attention to what I said at the beginning is something you really shouldn't do. But the idea is you don't want to run your jobs here. It's okay to run MATLAB here. Let's say I wanted to import some files into MATLAB. That's totally fine. You just don't want to submit your MATLAB or run MATLAB submit your jobs here. But that's the LMOD, aka the application module system in a nutshell. Back to my slides. You can list your modules, which shows you everything that you currently have listed. You could search by saying module spider and then the name of your software. There's tons of different software. So I would start, if you need to use software on the cluster, start with the module search. Module spider, sorry. And then module load, whatever version. And then you could list again to see if you have it. And now to remove the module, you say module purge. Module purge is just going to remove everything. So when I say module list again, nothing's loaded. And if I say MATLAB again, it again is confused by my MATLAB. Okay. So modules and tool chains. You load modules with the same tool chains in your job scripts. What's a tool chain? A tool chain is it's an HPRC thing that we kind of call them. a toolchain is a collection of compilers and libraries. So these examples that we have here, Intel, IOMKL, FOSS, and GCC Core, those are examples of toolchains. And then each toolchain here has different versions of it. So you'll see Intel 2018, Intel 2019, Intel 2020, that sort of thing. Typically, the older toolchains are the more stable ones. The newer ones are, the newer the software is inherently a little bit less stable than older stable software. But the idea is whenever you're loading modules that were built, you want to load modules that were built with the same compilers and libraries that you're using. So yeah, so the software that we have down here at the very bottom, you see HiSat 2/2.0.4. So that is telling you it's this software, HiSat 2 / and then the version of the software, 2.0.4 dash, and then after the dash is the toolchain that it was built with. So this tells me that this software right here, HiSat 2, was built using the FOSS, which is the free and open source toolchain from 2016B. And then this version of Top Hat, version 2.1.1, was built using the Intel 2017A toolchain and Python 2.7.12. So if you needed to load HiSat, Top Hat, and cufflinks, ideally you'd want everything after the dash to be the same. So you'd want HiSat to be built with Intel, and you'd want cufflinks to be built with Intel, and you also want it to be from the same year. So although these are the same Intel toolchains, they are from different years, so there might be some slight differences. In fact, there probably are slight differences, which is why they're separate toolchains, which will cause some issues when your job starts running and it all of a sudden gets very confused because you told it to use ICC, and now there's two versions of ICC and it doesn't know which one to use. So that's the idea there. Match your modules and toolchains. Yeah, okay, so let's talk about consumable computing resources. When you submit a job on Terra and Grace, you're going to create a job file. In the job file, you're going to specify all the parameters for the job, and the parameters are the resources that you want your job to have access to. Those resources include processor cores, memory, wall time, so how long you want the job to run for, and a GPU, like if you're going to use a GPU or not. All of the top three of those, cores, memory, and wall time, go into the calculation of your SU amount. So SU stands for service unit, and it's what you get allocated when you apply for an HPRC account. So although the clusters are free, as in you're not paying to use them, you get allocated a certain amount of SUs, and then as you submit jobs, the system charges you SUs based on how many cores, how much memory, and how much wall time. The exact calculation of SU, it's a little complicated, but think of it as 1 core per hour or 2 gigs of memory per hour. There's an exact formula that's on our wiki. I think yeah, this page might actually have the exact formula. I'm not going to go into it, but 1 core per hour or 2 gigs of memory for 1 hour is equal to 1 SU. So as a student, you're allocated 5,000 SUs right off the bat. So think of that as like 500 core hours, basically. And once you exceed that 5,000 SU balance, you can use more SUs, but you need to have your PI, so your advisor or whoever, the professor or faculty member whose research you're working on, they're going to apply for an account above a basic, which is called a startup account. And on their application, they're going to list you as their researcher, and they'll be able to send you SUs from their account. So at the very top tier, we have research accounts, and then beneath that, we have the startup accounts, and then beneath that, we have the basic accounts that students get. So basic accounts get 5,000 SUs. Your professor can get 250,000 SUs twice per fiscal year. The fiscal year just started, so if they don't have a startup right now, they can apply for one and get 250,000. And then from that 250,000, they could send you SUs. Typically, most researchers will like exceed if they're like doing, most of the time, if they're doing research, they'll exceed the 5,000 that they get from the basic, and then they use the professor creates a startup and sends them SUs for that. Most most professors and projects use 1 or 2 startups. Very rarely do the allocations get larger than that. But in the case where there's a big need, they can apply for a research account, but those research applications are scrutinized a lot more, and a lot more goes into them. But they start at 2 million SUs and go theoretically to infinity, or as much as A&M is willing to pay in electricity, I suppose. So that's my little spiel on service units. It's basically what you'll be charged when you submit jobs. When you run out, you got to go to your professor and ask your professor to create to apply for a startup, and then they can sub-allocate you SUs. You can't sub-allocate SUs to your friends. So like, let's say Daniel is, he runs out of SUs and I have 5,000 in mine. You can't send them sideways. So you can't send SUs from a basic to another basic. They have to come from a startup above them. So yeah. Oh, and also SUs are exclusive to the cluster that they're allocated to. So your Terra, you have 5,000 on Terra, you have 5,000 on Grace. So if you need SUs on Grace, you have to apply for an allocation on Grace. Yeah, so you can't transfer your Terra SUs to Grace or vice versa. Okay, and then licenses. So I talked earlier about software that's like restricted license software. That software that is like, it's typically small software that's used by like a specific group. There is other software that does require licenses, which is available to everybody. A perfect example of that is ANSYS. ANSYS requires licenses whenever you create processes from it. We, as an HPRC, hosts a license server where you can check out licenses from. It automatically checks out licenses as you run processes, so it kind of happens in the back end. The only interface that you would have with it is if you're trying to run a software that's kind of popular. Again, ANSYS is the go-to choice here, and other users are already using it. The licenses are a first come, first serve thing. So you might get an error that says no license is available. In that case, you just kind of have to wait until the license becomes available. In some cases, we do see users kind of hoard the licenses. In those cases, we've reached out to users and said, hey, this is a shared resource. You can't use all the licenses all the time. Other people need to use them. So if you're running into an issue like that, reach out to us and we can investigate it. But most of the time, it's just you're gonna have to get a little clever with when you submit your jobs, because sometimes, especially towards the end of the semester, for sure, there's a kind of a rush to submit these jobs, and the licenses can be in use. So you don't want that to happen. We have a license status checker tool. You can call it by saying license_status, similarly to how you said show quota. You just say license_status minus A. That's going to show you all the software. I'll demonstrate that right now. License_status minus A, and it prints out all the licenses for all the software. There's a whole lot of them. That's not really useful. Oh, it looks like all of the MOE licenses are. There's only 3 of them. So if you want a specific software like ANSYS, it's -S in the name of the software. And now I see not a whole lot going on. Like 77 Maxwell licenses are in use by the same person. But yeah, so you could check the licenses like that. You could see we have 1,300, 1,375. Okay, and then I forgot to mention the SUs. To check your SU balance, the command is my project. So my project. And it shows you your allocation. So I have 1 allocation for this fiscal year. Here's the account number. Here's the fiscal year for it. Is it my default account? Yes. And the allocation, so this is 5,000. So you can assume that this is a basic account. I've used 44 doing something, I don't know what. And then the name of my PI, Drew. Okay, so that's licenses and SUs. Oh, okay, I just talked about this. Yeah, list your SU balance, my project. So remember, we got my project for your SUs. To check the status of your hard drive, your drives. You can't see the air quotes that I'm doing, but hard drives. That's going to be show quota. Show quota shows you your quotas. My project shows you your SUs. Okay, batch queues. So now we're going to jump into actually scheduling jobs. So now that you kind of understand the software a little bit, hopefully, and how you kind of get charged for submitting jobs, you can this is what the queues look like on Terra. You could see this info using this command right here, sinfo or sinfo. It's going to show you all of the partitions, aka the queues that your jobs get submitted to. It's going to show you how many nodes are available, how many nodes are idle, offline, and then total. And then similarly, there's a column for CPUs. So back over here on Terra, let's say sinfo. So we see the short queue, the medium, long, and GPU. Now, the main difference between these queues is the time. There's basically two limits: the size of the job and how long it runs for. If you submit simple jobs, they're probably going to get put on short. So in the short queue, we see we have 250 nodes available. Of those 250, only 2 are idle. 4 of them are offline for a total of 256. And then here's the amount of CPUs. So if you're submitting a job and the job is pending, when you submit the job, the job submission tool will tell you what queue or what partition your job was sent to. And you can use that information to check this partition and say, oh, there's only 2 idle nodes. Well, I needed 3, so that's why it's pending. Okay, what you've all been waiting for, a job script. So this is what a job script actually looks like. It's just a text file. At the very top, you have a whole bunch of SBatch commands. The technical term for these are called directives. You know it's a directive because it starts with the hashtag, and then it's immediately followed by SBatch. So hashtag SBatch says, so first, what this is saying is we want to interpret these commands as a bash script. So at its heart, a job script is just a bash script, but it's also got these comments here, which when submitted to SLURM, the job scheduler, SLURM sees the comment and then immediately followed by an SBatch and says, oh, this person wants me to interpret this as an option or a parameter for this job. Technically, they're called directives. So this is a SLURM directive. And it's directing SLURM to request this amount of resources. So in this case, export none, get user environment L. This is going to replicate the job environment. So your shell environment, it's going to copy the path and stuff, and it should copy the path and replicate that across all the nodes all the compute nodes that this job gets assigned to. Beneath that, you see job dash name equals job example. Very, very simple. That's setting the job name. Time equals some time. This is how long, this is your wall time. So this is going to determine how long your job runs for. The syntax here, hours, minutes, seconds. This job is running for 1 hour and 30 minutes. End tasks is how many cores you want to run. So this is going to use 1 CPU for 1 hour and 30 minutes. And then beneath that, you see memory. Memory is specified per node. So mem equals 2 Gs. 2G means 1 core, 1 CPU for 1 hour and 30 minutes and 2 gigs of memory. And then you specify where you want the output. So we're saying send the output to standard out.%j. So this is actually a path. So if you were to submit this job, the output for this job would get placed wherever you submit this job from, and the name of the output will be stdout.%j. %j is a variable for the job ID. Whenever you submit a job, it gets assigned a job ID by SLURM. The optional specifications are the account number. So if you want to, I only have 1 account, so in my case, it'd be redundant to do this. But if you have multiple accounts, let's say you have your basic account plus the account from your PI. If you want to charge your PI's account, you can edit this number and say, okay, charge my PI's account. You can only charge accounts that you have permission to charge. So if you tried to enter the account number that I showed you earlier when I showed my project, it would just give an error. So don't even think about it. You can't do it. It's not going to work. Only the ones that you have access to, aka the ones that show up when you do this. So only these account numbers you can charge. So I dare you to try it. It's not going to work. Actually, no, I don't dare you to try it. No. Okay, so the other optional specifications are mail notifications. So if you submit a job, there's a chance the job might be pending for a while before it actually starts running. Again, it's a shared resource. So you could enable this. This is going to say, okay, send me an email. This one here says mail type all, as in mail me when it starts, mail me when it ends. And then you provide an email address to send an email to. Okay, so once you have all the job parameters out of the way, The job parameters, again, define the amount of time and the amount of resources your job wants to have access to. You define those parameters, you submit this to Terra or to SLURM. SLURM will find a space on the cluster with resources that fit your job. And then it's going to actually type in and run these commands, or it's not going to type in, you're going to type in, and it's going to run the commands that you typed in. So then it executes module load Python 3.7 Intel 2018b. And then it's going to /run myprogram.py. So this job script right here takes these parameters, puts them somewhere on a compute node, and then runs your Python program. So that's what I meant earlier by when I said you shouldn't be running you shouldn't do Python app.py, which is the same as Python myprogram.py. You shouldn't do that on the login node. You'll create a job script and then submit it to SLURM, and then SLURM will find a place for it on the compute node. Also, the compute nodes are going to be like generally faster than login nodes because there's a bunch of people on them using the resources anyway. Okay, so mapping jobs to cores per node on Terra. So we saw n tasks, which is the value of CPUs. So when I say n tasks equals 28, what I'm saying is I want to use 28 cores total, and then you add a line beneath that that says you can, it's optional. If you just say n tasks 28, it's going to put all on one node. But if you add this line beneath it, tasks per node, you're obviously telling SLURM how many tasks you want, how many CPUs to allocate per node. So in this case, 28 by 28 says 28 cores on, with 28 cores per node gives us one compute node. So you're using an entire compute node. Remember on Terra, 2 sockets, 14 cores each for a total of 28 cores per node. So this is requesting an entire node. This might take a while because for this to work, you need an entire node to be idle. You saw there's only 2 idle nodes right now. And those idle nodes might have one CPU being used on them, which eliminates that node from, you wouldn't be able to use it because you need all 28. So this next example says, okay, n tasks 28, let's keep that 28, but let's split it up 14 per node. So 28 by 14 gives us 2. So this illustrates that we have 2 nodes, 14 cores each. And then lastly, in C, example C, we have 28 cores split 4 ways, 7 cores per node for 4 nodes total. The idea here is that when you split up your job, you can increase the chances that it will run. So you'll decrease the amount of time you spend waiting in queue. This is like during busy time. If it's really not busy, then it doesn't really matter. Put everything on one node. But if it's busy, your job could benefit by splitting it up, and it'll run. It'll actually start running faster. The drawbacks here is that when you start fragmenting your job too much, there is inherently more overhead between the communication between nodes. So whereas example A, all the cores are just talking to each other on a single node, in B, these 2 nodes have to communicate with each other. Now on C, these 4 nodes need to communicate with each other. So eventually you're going to plateau and see that splitting your job up across more nodes will actually result in a slower job completion time because the overhead of communicating outweighs the benefits of running on a single node. So that's how you split up. That is how you split up jobs, tasks per node. Pretty simple. Okay, important batch job parameters. We basically went over all of these. Again, the first 2 initialize the job environment. The next one sets the time. After that, n task sets how many cores or tasks you want to use. Tasks per node is the same thing as cores per node. It tells you how many cores you want on each compute node. Remember, each compute node has 28 cores that you can use. And then memory specifies how much memory per node. You specify that in gigabytes or megabytes if you really want to, but gigabytes is probably better. Okay, n tasks equals 20. Tasks per node, n tasks equals 80. Tasks per node equals 20. How many nodes is this job requesting? Pop quiz time. Looks like we had an answer over here. Oh, we had a question. Do we have to specify time limits for the jobs when submitting? Yes, you do. If you don't specify a job, if you don't specify a wall time, actually I don't know if there's a default wall time that gets put in for you. The wall time is like the most important part, I would say, of the job. So yeah, you definitely need to put one in there. You could just kind of estimate it and say like, if you overestimate it, you're going to get that time refunded back. So you should always put a time in there. You might get an error if you try to submit without a time. Good question though. So, okay, the answer to this is 80 tasks, 80 cores divided by 20. So we're going to request 4 total nodes. This job script will, you're welcome, will request 4 total nodes. Okay, so here is another job file example. I'm going to skip over this because there's some other stuff that I want to talk about. But these job files are available on our wiki. So if you go to hprc.tama.edu/wiki and then find the Terra section of that, there's the Terra Quick Start Guide, which is basically this information in wiki form. And a lot of first-time users, what they do is they go to the wiki and they copy the example job files, which is what this is. You can copy this and put it into a text file, upload that text file to Terra, and then you have a written job file that you just need to modify. So all you do there is you modify the time, modify the number of CPUs, modify the memory, and you could submit it. That's perfectly fine, and it's probably recommended, so you don't have to memorize all this stuff and write it down. You could just take the examples that are on the wiki, copy them, and then modify them as needed. You'll just change the modules that you need to load, and then the steps you take. But that's the easiest way. This example is, we've basically seen it, 1 core, 2 gigs, 1 hour and 30 minutes. Okay, so to actually submit your jobs, you're going to use SBatch. So whereas in the job script, you yelled SBatch at SLURM, when you submit it, you call SBatch just like this, a little bit more quietly, not capital, just from the command line, you say SBatch and then the name of the job file. So example 01.job would be the actual text file with all the SBatch directives. And all you'd say from the command line here would be SBatch, and then whatever you name your job file. I would say, like, it's smart to either name them some file .job or .slurm, just so you know that it's a job file. But when you do that, it's going to submit your job to Slurm, and this is what you'll see: submitted batch job, and then it gives you the ID. It tells you how many SUs, it'll tell you the account that you're going to charge and how many SUs it's going to take. And then to check the status of the job, so you could see whether the job is running or if it's pending or if something's happening to it, whatever's happening, the command is SQ UE minus U and then your username. So this will show you all of the jobs that Slurm is currently tracking for your username. Obviously, I do it on myself. I don't have any jobs running right now, so it's pretty useless. But if you do it without the minus U, this is going to show you all the jobs that are running on Terra. There's a whole bunch of jobs running. So yeah, so SQ minus U and then your username shows you your jobs. And you'll see its state. So is it pending? Is it running? And then the reason for that state. So this first example right here is pending. The reason it's pending is resources. So the resources are not available yet. The second example right here, submitted by some user, is running. And then you also, you get a node list, and the node list is the name, the host names of the compute nodes that are actually running your job. So like I said, they get sent off to compute nodes that run them. So in this case, this guy, some user, his job is running on TNXT-0401 through 0404. So it's 4 nodes. Node 1, 2, 3, and 4 are all being used for his job. Okay, so continuing on job submission tracking and submission, SBatch is the command to submit your job. SBatch and then the name of the job file. SQ with your minus U and your username will show you your job. If you want to cancel your job or kill it, it's SCancel. And then you give it the job ID. You get the job ID from SQ. S account does some stuff kind of out of scope. LNU and PE stat will show you resource usage for your jobs. So LNU, I believe, will show you resource usage after the job finishes. And then PE stat shows you usage for a running job. So if you're submitted a job and you want to see, let's check the CPU usage or the memory usage, you can use PE stat while the job is running. If you want to see how your job performed, so you submitted your job overnight, you woke up in the morning, you saw your output. The output doesn't exactly look like what you wanted it to look like. So you can go check the performance of your job using LNU and the job ID. Again, you can get the job ID from SQ and you give LNU the job ID. So like 1, 2, 3, 4, and it would say, okay, jobs 1, 2, 3, 4 ran on nodes 1, 2, and 3, and it used 10 CPUs. And those 10 CPUs ran at 30% efficiency. And you're like, oh, 30% efficiency, that's not very efficient. Yeah, and you can go from there. Here's a job file example. Again, gonna kind of go over this really quickly. This is a multi-core single node. So here we're explicitly telling SBatch. I should also mention all the directives that I'm talking about right now. It's not an exhaustive list by a lot. There's a lot of directives. It's just kind of the core ones that are really that are super core to kind of getting up and running. So this is a new one that we just see right here. It's called nodes, and you could probably guess that it is explicitly telling Terra, okay, I want to use one node, and I want you to put 14 cores on one node and give me 28 gigs of memory. So roughly half of this node, 14 cores and 28 gigs. And then here's the little SU calculation right there. If you try to submit a job and you have insufficient SUs, it's just gonna tell you no. It's gonna tell you no and say, hey, you don't have enough insufficient balance. Contact your PI if you need more SUs. Okay, and then the last thing is CRLF line terminators. This I've added in here because when you're running, so if you create a file on Windows, so let's say you have your Windows computer and you use like Sublime or something, Sublime actually might fix it automatically, but sometimes when you're using a Windows machine, the enter character on Windows is not the same as the enter character on Linux. So Linux won't really know what it is, and it'll freak Linux out and it'll throw some errors. So if anytime you write a file on a Windows computer and then move it to Linux, you're gonna wanna run DOS to Unix on it. It's this command down here. DOS to Unix takes a Windows file format and converts it to a Linux file format. It's really simple to use. You'll know that you need to do it if you take a file like DOS_text, which was written on a Windows computer, you put it on Linux, so you put it up on Terra, and then you run this first command on it, file. File says, give me information about this file. So file returns that DOS text is an ASCII English text file with CRLF line terminators. So CRLF, remember, is the bad Windows characters. So you see these and you think, oh, this was written on a Windows computer. That's not terrible. We could fix that really easily. But if you just tried to send this to Linux, or if you tried to run this in SLURM, using SLURM on Linux, you're going to get an issue, and it's going to return an error, and SLURM's going to, the Linux part of SLURM is going to be like, I don't know what you're talking about. So just always remember DOS to Unix files that you move up from a Windows machine, and then you can run file again, and you'll see that the line terminators are gone. Okay, so we went through that kind of quickly. So if you guys need help, I recommend the wiki and the FAQ on the wiki. The wiki has a lot of knowledge, and so we basically use the wiki to build these slides like this. There's a Terra user guide, which kind of goes over everything I talked about in a little bit more detail, which will take you longer than an hour to read probably, because there's a lot. And there's also some exercises there that you could work through. Those are just examples of creating jobs and submitting jobs and stuff like that. If you have any questions about HPRC or its resources, you can email us at help@hprc.tamil.edu. That's how you reach our help desk, where I work and the other students work. We'll get back to you. When you email us, please include this information, like which cluster you're using, your net ID. We don't need your UIN, just your net ID. Your job IDs, if applicable, the location of your job file, applications, modules. If you're getting error messages, including the error messages is always really good, so we could just kind of go from there, and steps you've taken so we can reproduce the problem. But other than that, I think that's all I've got for y'all. So everybody in Zoom, thank you guys for attending. Everybody in person, thank you guys for attending. If there's any questions, I will stick around to answer them. Oh, okay. A question. Is HPRC charging SUs for Grace now? They're trying my project on Grace, and they give me a message saying accounting is not enabled yet for Grace. They're not. It should be enabled now. There we go. It will be enabled very soon. Yeah. I think we're still working with that because Grace, like I said, is our largest deployment. There's a lot of stuff that goes into that. So we want to make sure that from the user side, the users won't have the users will have a good experience using it while we start charging them SUs, because we don't want to bill you guys SUs and then your job starts failing, because then one, that's very annoying to you, and then two, that creates a lot of headache for us because we need to go back and reverse those charges. There you go. You can run real-my project. Okay, so the other question is, there seem to be fewer software on Grace now. Will there be a C/C++ compiler on it? Yes. Okay, so the reason you're seeing that is because, and this is a key difference that we're going to talk about in the Grace primer. It's that Grace and Terra both use the LMOD system to organize their modules. So you're still using module spider and module load and that stuff. However, on Grace, the modules are organized in a hierarchical architecture. So at the very start, you start by first you load the compiler that you need. So at the very bottom, you load the compiler first, the tool chain first, and then you load the software. So it's a little bit different. You're using the same command, same syntax. It's just a different order that you do it in. We're going to talk about that more in the Grace primer next Friday at 10 a.m. But that's the short answer. And then the other answer is there's fewer software on Grace, like just the number, because Grace, like I said, was just kind of Grace is essentially brand new, whereas Terra has been here since since 2017, 2016. I forget when Terra was deployed. So over time, the collection will grow. But yeah, there are C and C++ compilers on Grace right now. I hope that kind of answered your question. No problem. Are there any questions for the in-person people? Any questions? Are y'all good? Okay, I won't keep y'all any longer. Thank you guys for showing up. I really appreciate it. As for everybody on Zoom, if you have any more questions that you can't think of, send them in an email and we could address them. Otherwise, I will see you guys at the Grace primer on Friday, a week from today, 10 a.m. Thank you guys.